So welcome to this tutorial which is going to look at how to create a wet map in Houdini. A wet map is a way of storing information about where a fluid has passed so that you can shade the surfaces it's passed over correctly. Now there are a number of example files that come with Houdini which show how to do this using volume fluids. This tutorial is going to look at how to achieve the same effect using particle-based fluids. So first of all, I'm going to set up a very simple particle simulation. Let's lay down a box and enlarge it until it covers almost the entire screen. And then I'm going to lay down a transform node in order to tilt the box. Now the reason I'm doing this at geometry level rather than scene level is because that makes it easier later on when we import DOPS information into the scene. The second thing I'm going to create is a sphere, and I'm going to position that over the top of the box. So there we are. Now I'm going to create a fluid simulation. First of all, on the rigid body tab, I'm going to select the box and I'm going to make it a static object. And then I'm going to select the sphere and I'm going to make it a particle fluid object. Let's just dive into our AutoDOP network and lay it out a little bit better. And let's bring up a parameters pane. Now, with the sphere object, which is our fluid, I'm going to change some of its properties. First of all, I'm going to increase the particle separation to 0.2 because that speeds up the simulation. Obviously, if you were doing this for real, you would want quite a small particle separation. And the second thing I'm going to do is give it a little bit of jitter, which helps to randomize the position of the particles and gives a more realistic result. Let's just very quickly run over the nodes that have been placed down here for us. Over this side we have our box and our static solver, and this is merged in with our fluid, the fluid solver, and this pop solver here, which is the thing that actually creates the particles. And right at the bottom, with the display node, we have gravity. On the box object, I'm going to change the friction and the dynamic friction scale in order to get a slightly better simulation. So let's see how that looks. That's fine. So the aim is to collect information on where this fluid has flowed and store it in a way which we can retrieve when we come to shade the box. In a real situation, you might also want to cache out the simulation and then read it back in for the subsequent steps, but since it's rendering quite fast, I think we'll just leave it as it is. So the first thing I'm going to do is scatter some points over part of our box. I'm going to select the top face of our box. Now unfortunately in Windows the group is not being picked up for this. I happen to know that the top face is primitive number 5, so I'm going to enter that manually. And as you can see, we have some points scattered across that top face. I'm going to leave this at the default of 5,000 points. The next thing I want to do is import the DOPS fluid information into this object that we're in now. In fact, I can do that by looking into the sphere object. Let's open this up and we can see that we have a DOP import and a particle fluid surface. We've also got another DOP import which is visualizing that fluid surface. This DOP import is in fact importing a particle system which is then being skinned, if you like, by the particle fluid surface. So it's this that we want to replicate in that other object. So if I copy it, and then go into our box object, we can paste it in. Now this only works because we don't have transformations on our objects at the scene level. I'm going to use a attribute create SOP to add some information to the points that are coming in here. And what I'm going to add is an attribute, and I'm going to call this DOPS wet. And we're going to leave it as a point attribute. It's a float attribute. Default value is 0, but the value on these points is going to be 1. Now I need to rewire this side of the network because we don't want the scatter going into the DOP import. We want to use an attribute transfer SOP to get information from this DOP import and transfer it to the points that we've just scattered on the surface. Now the reason we've used a scatter here rather than simply subdividing the box to provide enough points for the detail that we'll need is because the scatter creates a random outlay of points, and that makes it slightly more realistic when it comes to render time. Attribute transfer is a SOP which takes attributes on one bit of geometry and transfers them to another. And we specify here what attribute we want to transfer, and that is going to be DOPS wet. And the second tab allows you to set how sensitive it is to transferring the attributes. And the key thing here is this distance threshold, which I'm going to set to 0.1 for the moment. What this does is look for the nearest point from these points here to the point we're considering in here, and if it finds a point within a distance of 0.1, then it will transfer the value of DOPS wet, i.e. 1, to the point here, which comes from the scatter. If it doesn't find a near enough point, then it gives the point here a default value of 0. So what we should find is that our points here have either a 0 or 1, depending on how close they are to the liquid. We can visualize this using a group SOP, and instead of grouping by pattern, I'm going to group by an expression, and that is going to be using the attribute we've just created. So in this case, let's have a look. It's not a primitive group, it's a point group. Let's just re-simulate that. And see how many points we have in the group. 331 points out of 5,000 in that group.